Good evening, everyone. Thanks you very much for introducing me. I'm really happy that you are here to listen to the pre-last presentation. And you are already very strong that you survived until this moment. It's just 2 presentations to go. I would like to talk in my presentation a little bit about application of data analysis, and particularly how can we apply data analysis for discovery of decision models complementary to process models. So I have here 2 things. Just a very short background where I'm coming from, so that you know a little bit about my background, in which companies I have worked. What I have been doing recently, the last 5 years in particular, I was doing a doctorate at Hasso-Plattner Institute, and the material which I'm going to present today was mostly done in collaboration with Hasso-Plattner Institute. Currently I'm working at KPMG Lighthouse. It's the data center of excellence for data analysis and further intelligent automation, robotic process automation in Berlin. So that's where I'm working now. And here I am today with you, and let's now go to more interesting stuff. So we have talked so much yesterday and today about the data, so data is just everywhere. So I like this quote which says that data or information is a source of learning, but unless it is processed and organized to the right people in a format for decision making, it is rather a burden, not a benefit. So let's see how can we apply data analysis for improving our decision making. So here we go to our motivation, and in this slide I represented a typical structure of how enterprises look like, and normally there are 4 layers where you can see their business architecture layer, the applications layer, data layer, and the underlying technology layer. So where I am now in this presentation, we're talking about business architecture layer, and that's where the process and decision models, they come into play. So why do even we bother with modeling decisions and processes? So first of all, it increased transparency, so between the people who work in their enterprises, between all the involved stakeholders. Secondly, models provide us opportunities for automation. When we model these processes and decisions, we can later automate them, so therefore we can save costs in the future. Last but not least is compliance. So especially in the light of recently emerged GDPR law, which, for example, says that users can apply for explanation of decision making, which was made on them. It is important for companies to be able to explain visually and logically the decisions which was made on people. So that's why it is very important to be able to have this modeling capabilities at enterprises. So how do we achieve that? I like to introduce my my work with on simple examples. So imagine that you're a client who is coming to a bank and applying for a credit. So this is a typical process model of a decision credit risk assessment process, which the bank normally does on people. There are some steps like collecting the data about you, and then based on some decision logic, there is some decision which is made on you if to give you credit or not. And this is a traditional way how companies who already use process modeling, how they represent the process model. And as you can see here, the decision logic is embedded in the control flow for process models. Recently, the separation of concerns paradigm has started to gain an importance, which says that it comes from programming, and it says that it's important to model decision logic not inside processes, but rather outside of the processes in a dedicated decision models. Because if you can understand that upon expanding of such process models, you get such spaghetti, like we call it spaghetti-like decision process models. And it's very uncomfortable because when you implement these process models later, it becomes very hard to maintain these processes. And when, for example, some changes come from the external environment, you have to change this control logic which is already implemented. So this is considered not as a good practice. And in the last several years, this OMG group, the Object Management Group, has come up with a new standard which is called Decision Model Notation, or DMN standard, which says that decisions should be modeled complementary to process models. So in DMN you have 2 layers. You have decision requirements diagram, which shows you decision which was made, and also the input data which is used for these decisions. And then you have the decision logic layer. So one of the most used ways to represent decision logic is decision tables. So these 2 layers, they comprise together the DMN model. And thus, you can refactor your process models as, for example, this is the same process model as here, but now the decision is hidden inside this decision activity. And when the process model is invoked during the execution of the process, so then the corresponding decision model is invoked. So what's the problem here? So how can we get these decision models? So there can be two ways how decision models can be designed at enterprise. So the first obvious way is designing by experts from scratch. Sometimes it's, of course, the only way, especially for new processes or if no decision models exist at enterprises. The disadvantage here is that sometimes experts, they think that they know what's happening and they model the desirable reality. But somehow, any model is an abstraction. Not always the models represent really what's happening in the enterprises. So then there can be a second way of how we can get the decision models. And what if we can derive it from the existing knowledge about the process? So that can provide, firstly, automation opportunities if we consider the data. So now, like, we don't have to involve people so much to design these models. And that can be good for enterprises. The advantage of this approach is that it's based on reality. So maybe we can take the existing data, the existing execution data, and then we can extract models from them, and then we'll see the real decisions which are happening. So this approach was already implemented by many stakeholders like SAP, Oracle, Signavio. So like you have a lot of these frameworks where you can model decisions and processes. And what we discovered that mining of these decision models has not been addressed yet. So that's where our approach lies, so like in this area. So let's see now talk a little bit more about this existing knowledge about process, what I've been talking about. So the first one is a so-called event log. So event logs are recorded by information systems of enterprises. So, and it's normally some activity stamps which are recorded and some data attributes which are recorded in parallel to these activities. So as you can see, the disadvantage here is, for example, you can see there are activities register claim, like in a credit risk process, and then we see that some decision like risk is 3 was made. And that's what normally banks, for example, have for their information systems. What's the problem here, really? The problem here is that you don't see the logic, right? How this decision was made. So, okay, there was this data, and then the expert decided, okay, I'll assign the risk number 3, of course, based on the expert knowledge. But however, when you then have to explain to user how did you do this decision, so some maybe incompliances can be discovered, so to say. And then we have a second source of potential knowledge about decisions is if companies already have process models at place, because some companies already have repositories of process models. We can also use them to extract decision logic from these process models. So in our work, we address these two perspectives of mining their decisions from process models and from event logs. Now I would like just to put it in a bigger picture so that we zoom out a little bit. So we do have a world where real processes are happening. Then we have a process-aware information systems which can record the event logs, as I showed you before. There is a discipline which deals with mining process models from event logs. It's very well established discipline. There is for example, very famous researcher, Professor Wil van der Aalst, and he has a book on this, so there is really, if you Google, you will find lots of information about that. So it was not part of our approach, we already used the existing techniques. So what we did is we provided a framework, formal framework for modeling decisions complementary to process models, and provided the approaches to discover these decision models, firstly from event log, and secondly from process model. Since it's a conference about data analysis, I would briefly only provide you with an overview of this event log analysis, since it's more connected with the data analysis. And here I'll just provide you with the methodology. So let's come back to an example. As an input, we have an event log, so as I showed you before. Firstly, we discover the process model, so with existing process mining techniques. And then we needed to provide the algorithm which will discover decision mining. So you can see here that this decision model corresponds to the process model. So for example, when you as a client come to a bank, it is one instance of a process model. So you're one instance of this process model, so to say. And then based on the concrete data about you, for example, you ask for 1,000 euro for this time or a period of time, and then the decision is made about you. And then when the process is being executed, at these points, this decision model is invoked. As I also mentioned before, then we have the decision logic behind. So let's, how do we do this? So here is our methodology. As an input, we have event log. As I said, we discover with the help of process mining the process models. There are some technical assumptions which I'll not go here so much in this presentation, but we can discuss it later if you're interested. So firstly, you do the discovery of decisions. And here it's basically their standard data analysis methods, like you can apply decision trees, or you can apply neural networks, or you can apply different kind of algorithms. And so this is what standard data mining field is busy with. So what we do in our work is we go in one step further. So after discovering this decision with standard data mining, we map them to these nodes in the decision model. Then we discover the dependencies between this decision model, and these dependencies then are reflected in the output decision model. So that's basically the overview of the methodology. So if you're interested, you can find in Google some publications on this. So there we have done some experience with different approaches on this. So for example, one obvious classifier which can be used here is a decision tree, because it provides good comprehensible results, because that's important for businesses. You discover not really giant bases of decision rules, but rather small sets of comprehensible rules, and then they can be used further in businesses. So I would like to talk a little bit about the evaluation, the interesting part also of this research. And so, like, to be able to evaluate our approach in the real-life environment, we developed a prototype. There is a platform which is called PROM, and it is an open-source, free tool for process mining. And there are a lot of tools, and you can all try them out. So it's all completely free, and it's being developed, and it's widely used. And then there is this Veka. It's a Java-based library, which we used as a basis to create our own plugin for this PROM platform. So this is an overview of their software, and here is our contribution. So we provided the so-called decision miner, and it has this extract of DMN models. We use DMN because it's widely used by their industry, so it's good interoperable standard. Then there were some extensions which I'm not talking today, like fuzzy decision mining. You can also, if you're interested, find it in my works. This is how the interface looks like. Never mind, it's just a research prototype, so it was not meant to look very nice, but it provides everything what you need. You take an event log as an input, and as an output you have decision requirements diagram. Then when you click on different tabs, you can get the decision models. Here are the decision points for this model. Then we took the data, and we found open source open road fines event log, which was recorded for many years by the Italian police, and we had enough of data to conduct our experiments. So it's important to know that before any application of methodology, you have to do certain pre-processing of real-life data. For example, incomplete process instances were not relevant for our model because you can't really use them in the decision model, right? If the process was not finished, it cannot become a decision rule in the model. Then we excluded very rare traces, so because they were really unlikely also to become decision rules. Then we eliminated loops. As I said, it's a technical obstacle for decision mining, and still, like, lots of data was kept, so we can claim that results are quite reliable. So as an output of application of our methodology, we discovered a process model. So it's already good because you can see how this road fine management was organized. So you have some steps as creating fines, send the fine. Sometimes the payment was made directly after the police was given a fine to a person. Sometimes it was done online and so on. And what's interesting, we also discovered corresponding decision model, what was happening there. So here you have sometimes control flow decisions. So for example, this P1, if you go before, you can see that this is just a control flow routing of the process which was happening. So maybe which is less explanatory. But then sometimes you have these data decisions which represent rules over just purely over data. And this is an example of a decision table which was discovered for this event log. And there were some regressions discovered which can also be put into correspondence with corresponding decision nodes. So this is the output of the application of methodology. So just to remind you why were we doing this? So you can already use this decision model for automation. So of course it increases transparency because now you can analyze how the decisions were made, and you can see maybe there were some discrimination cases, and this it's next steps. I was not doing that, but this is what it can be used for further, and it can be used for compliance checks. The accuracy of the algorithms was quite good, so we used this event log, and we also used the simulated event log, and we applied, of course, cross validation. We put in some noise, and you can see that results are quite good. Of course, for the real life log, the accuracy, as we add more noise, goes down. So, but that's expected. So there are some certain limitations still of the approach. For example, still the expert involvement of an expert is needed, but as in many data science problems, right? So we couldn't exclude it completely. So first of all, you need to pre-process the real-life log. Secondly, if you find some circular dependencies, for example, if you find that duration is amount divided by rate, of course the approach will also find that amount is duration divided by rate. So you have to, now we just manually discard these circular dependencies, but maybe that can be optimized in the future. Then, as I mentioned, this looping decisions, it's a known obstacle, but it can also be, there can be some workarounds applied. Good news is that expert behavior can be learned, so some other people or companies can do that. Yeah, so let's conclude a little bit. We provided the formal specification of decision model that can be designed and executed complementary to process model. So in my work also provided approach for extracting these decision models from event logs and from process models. And there are these certain future work opportunities which I mentioned before. Of course, it's not just my contribution, so I'm very grateful for my co-authors, which were also part of this work. So they can be seen here in these slides. And yes, thank you very much for your attention. And if you have any questions, I will be available for some time after this talk, and I think after the next talk. So let's communicate if you are interested in process or decision mining, or in maybe intelligent automation, things where you can apply this methodology. Thank you very much.